In this video, I'm going to show you how you can create your own collection on OpenSea, have your own smart contract of your collection on Polygon and Ethereum, as well as a minting dApp in 3 very easy steps. My name's Daniel, aka Hashlips, and welcome to the channel. Welcome back to all the old members as well as the new ones. Like I said, I am going to show you the whole process of uploading your collection onto the blockchain, Polygon and Ethereum this time. The reason why I'm making this long video, this continuous video all in one, is because I want this to be the ultimate guide for people who are struggling. This will be beneficial for people who have already tried out this process, and for the new people who want to actually go ahead and create their collection from scratch. I've made it very easy by creating 3 packages that you are going to be using. I call it the 3O. If you follow these 3 packages, you should be good to go to just upload your collection onto the blockchain. I want to make a disclaimer though, everything I show you in these videos are all for educational purposes. So please review the code carefully before using it for production. I will not be held liable for anything you upload on the blockchain. That being said, I am using all these repos for my own projects. Let's jump in and let me show you how this is done. I am very excited for this video, and mainly because it's going to help so many people in the future. Now let's get started. If you head over to the Hashlips GitHub repos, you will find the repositories, the 3 main ones that we will be using. The 3 ones are called the Hashlips Art Engine, then the Hashlips NFT Minting dApp, as well as Hashlips NFT Contract. I will dive into each one in detail. But briefly going over them, the Hashlips Art Engine has to do with how we create the artworks. In order for us to create a bunch of artworks, for instance, a bunch of these nerdy coder clones or pixel art or whatever you want to create, we need to use some kind of program, and this program has been designed specifically for people who want to take layers of different images and have a program randomly combine them with different rarities, as well as export the metadata. This is exactly what this series is all about, is to start this process from scratch. But if you want an in-depth tutorial on the Hashlips Art Engine, you can head over to the YouTube channel, go into the playlists, and find this Create 1000 Generative NFT Artwork with Code series, this purple one over there. This series shows you from the start what to do. Now you can watch that series, and this is how we start building up this actual repo. So I suggest watching it till the very end before starting with your repo. But if you want a brief overview and just follow along, you can do just this video as well. All right, perfect. You'll see that each one of these repos has a nice description of what it does. This one takes layers and turns it into images, and there's a bunch of documentation that you can read through. Also on each of these repos, on the right hand side, there's a release. The current version that we are at today for the Hashlips Art Engine is version 1.0.6. Always check the latest version and the updates and download this one and use it instead. But if there's a video that you see I click on a specific version, rather go for that one, because it means that the code will stay the same if you do it over here. We'll download them in just a bit. The next piece of the puzzle would be this repo. This is the Hashlips NFT contract. Now the contract is something that we are going to deploy on the Ethereum or Polygon network. Now it takes code and it deploys it onto the blockchain in order for us to mint NFTs. And this is exactly what this repository does. I'll show you how to use it in just a second. Let's look at the third and final step that you'll be implementing. That is the Hashlips NFT minting dApp. If you click on this one, you'll see that in the documentation, This basically takes the code that we have written for a website, a dApp, and it looks like this. You can see that the dApp behaves in a nice and special way where it connects to the smart contract that we have deployed. Then people can simply click on buy and it will then start minting their NFT. You will have to have a MetaMask extension installed on your Chrome browser, and by having that, then you can start interacting with your smart contract, minting NFTs, and they will show up on OpenSea and start getting floor prices, volume traded, and a lot of owners. Now, those are the three main repos that we will be using. So I'm very excited. Let's get going. Our first step is to actually download each one of these files. So what you want to do is go into each one of these repositories, the Hashlabs Art Engine, click on the latest version, which is mine version 1.0.6 at the moment, go down and download this source code zip. So click on it so it starts downloading. Let's go back and let's go into the Hashlabs NFT minting dApp and we'll do the same. Currently this one is on version 1.0.0. So I'm going to download that source code, and yet I'm going to go back again and download the Hashlabs NFT contract. Also version 1.0.0. So download those three files. Once you have them, you can go and extract them in a folder. So there's my three programs. I'm going to select them and let's say unzip. So I have to basically unzip them each one by one. That's cool. We'll do that one, this one. So we've got this version 1.0.6, the engine. We've got the NFT contract and we've got the minting dApp. Perfect. The rest I'm just going to move to the bin. These are the folders that we'll be working with. Take note that these are simply folders with files in them. But it would be nice to work with this project with an IDE. So let's go download the necessary programs that you'll need in order to run this code. The only program that you'll need to install, both Windows and Mac can do this, is Node.js. Head to this page and install it for your operating system. Node.js is simply the language that we've written the program in, and it allows you to run it in a framework for us to access the file systems. So go ahead and install it. I will be using it for Mac and I've already installed and run the installation. In order to make sure that you've installed this correctly, you can simply open any terminal and run node-v. If there's a number coming up here, mine is version 14.17.6, it means that you've done it correctly. You can also check that you have npm, so npm-v, and you'll see that I've got version 6.14.15. Now, npm comes with Node once you install it like this, so that's all you need to do and run a test. Even though Visual Studio Code is not necessary to have, it's a great IDE that you can use. An IDE is simply a text editor, but that has more functionality. It colors the text and it looks great. It also is a useful tool for us to start running our Node commands for us to execute our programs. So go ahead and install Visual Studio Code now to follow along. Now that you have the programs installed, what happens if you follow along and you get stuck with a particular problem? Don't worry and don't hesitate to ask the community. We have a thriving community on Discord, which you can find by going to hashlabs.online. You can go to the Discord channel or the Telegram channel. Our Discord and Telegram are two thriving communities of developers and artists who come together to help each other out and use the programs that you are now seeing. So don't hesitate to ask anyone for help if you get stuck. But I'm pretty sure this video is going to be clear enough for you to not get stuck and own it. And lastly, for those who have seen all the videos that I create, I highly appreciate it if you guys leave comments and likes on these videos. It really makes my heart warm to see that the videos that I put out and the content is gratifying enough for you guys to react in such a positive way. I always appreciate it if you subscribe for more content, but that's up to you. Let's get going and creating your NFT collection. So the very first step in creating an NFT collection is deciding on what art you want to create. There are numerous NFT collections out there and they all have different styles. Come up with your own style, come up with a nice concept, and start creating the layers for it. This is the Nerdy Coder Clones collection, and you can see that all these Coder clones looks different. Well, they were all individual layers, and the program that we're going to run makes all these different ones. Now, you can apply this concept to any art concept as well. I'm going to take an example, and let me jump over to Photoshop. Your very first process would most probably be creating a cool kind of NFT concept and then separating the elements in layers such as these. You can see that by separating them into layers, such as the eye shine over here, you can kind of hide them and put them on, and it creates every time a different look and feel. For instance, you can have a small eye, you can have a cat's eye, you can have a different color eye, and by doing these things, you'll see that it kind of changes the image and the outcome of what you're busy creating. Now, this is the very same concept that we will be using for our program. Our program will be able to take all your layers that you've created, you split them up, you export them, and then you go and apply this to the Node program that I've written, and then you run it in order to create thousands of different artworks. The more layers that you have for your collections, the more possibilities and the more artworks you'll be able to create. I said this video is going to be a full explanation, and indeed it is. I'm going to show you your very first tip regarding Photoshop. If you have all your layers visibly selected by putting on this eye icon, you can simply go to File, Export, Layers to Files. Then go and browse and select a place and a destination to save this. I'm not going to put a prefix. I'm going to keep this as PNG. The layers is going to be only the visible ones, and I'm not going to trim the layers. That's very important. When I run this, you will see that it runs through my collection and exports each individual layer in its own file. This is very important because this is exactly what you'll need for the program to make use of it. This is way better than doing it manually. That's just an extra tip, and I hope you like that because it saved me a lot when I did not know this back in the day. So knowing this now, I always use this. So let's look at the next step after you have exported all of your layers. Once you have exported all of your layers, what you basically want to do is split them up into different folders. These folder names are very important. What I mean by that is if we refer back to OpenSea, your folder names would eventually, with my program, be the property names like this: nerd, purple shirt, coder, and so on. So, therefore, it is very important to have the folder names exactly spelled correctly how you would want it to appear on OpenSea. What you do with the folders are you split up the layers that basically goes to that folder, right? So for instance, the eyeball, I put all the little eyeballs inside the eyeball folder. For the eye color, I do the same, and so on. Once I have all my different layers split up in folders, I'm ready to go, and I can now pull this into the program. Something that I should mention at this point is that if you open a layer and you give your layers each a name, like I said, spell them how you would like to see it on OpenSea, maybe with an underscore if there's a space in the name. But the most important thing is that there's a hashtag and then followed by a number. Keep this in mind. If your program breaks, it's usually because this hashtag and the number is not there. You will see that all the hashtag and numbers are hashtag 10. I'll talk about the rarity when we're in the program itself, but just make sure that all of your files have a hashtag with a number. I usually create them all as 10, and that way it's easier for me to work out rarities later on. Now go ahead and open Visual Studio Code. You can go and say open over there and open the folder that has all those programs in it that we've downloaded in the beginning. You can see that we have the Hashlips Art Engine over there, which is 1.0.6. So I'm going to open this one. Simply just click on this folder, double click on it to open it up. You'll see that it's going to ask you to trust it. This is Visual Studio. And then we can see our folder structure over there. Perfect. Let's quickly import our layers that we've now created in Photoshop, our collection, into this program. So the very first step that you'll need to do is pull in all your folders. So let's go to this layer folder over there. If you open it, you can see that there's already a bunch of layers in there. I'm just going to simply select all of those layers and delete them. Then I'm going to take all my layers, and you are going to take your layers and drop it inside the layers folder. Make sure that it's in the layers folder and not outside of it or some other place. So you should have your layers folder with all your different layers, and inside of them you have your attributes, your items. And that's it. That's the very beginning. Keep in mind, like I said, maybe start off with a hashtag 10 or some solid number, because we will change it later on if we want to make some of these items more rare. Now, if you want to understand this program fully, you can go ahead and watch that purple series that I was talking about in the beginning. But to just get up and running and set up your collection, all you need to do is go here at the top where it says terminal. You have to say new terminal up there, and then you'll get a new terminal in your Visual Studio Code IDE. Once you have that, because you have installed Node in the beginning, you can now simply run npm install, like so. If you type npm install in your terminal and you click enter, it would start installing the dependencies for this project. Dependencies are programs and different libraries that we'll be making use of when we run this program for it to run successfully and build out your own collection. The dependencies might take a bit of time to install, but please remember you only have to install the dependencies once. So you only ever have to run npm install once to get this node modules folder in your project, and then you're good to go. After that, we'll just be running a single node index.js command every time we want to rebuild our collection. So give this some time to install, and then we'll continue going forward. Once the node packages have installed, you'll see something like this. It won't look exactly the same. For instance, this is my computer's name. That's a question that commonly pops up, so don't worry about this. Your name might be here for your computer, but if it's done installing, you'll see something like this. All right, perfect. So the next thing that we need to do is have a look at what do we need to change in order to make this run and work to test it out. Open this source directory and go to the config.js file. In this config.js file is the place where you will do little bits of changes, and this is the only place that you really need to change to build out your collection. The main place that you'll be changing is this layer configuration file. Each layer configuration exists of an object. If I close it over there with this little arrow, you can see that between these two curly braces, this is all of the object's content. So for each layer configuration, and you can have as many as you want, you have a grow edition to size, right? A grow edition size 2 basically. How many NFTs or artworks do you want to create? And what is the order layer? So in what order is this program going to generate these images? Okay. So for instance, this program will render a folder called background first, then an eyeball, then an eye color, iris, shine, and bottom and top lid, for instance. You have to make sure that in your layers folder that you have the corresponding, you don't have to have all these layers in this layer order, but if you include one of these folders, the spelling of this name, background, needs to be exactly the same as background. If it's in your case something else like mountain, it needs to be the same spelling and same mountain. All right. It's just very important because that's how the program picks up which one of these folders to grab next, if it makes sense. Okay. Then the other important thing here is to make sure that you organize these in the correct order, starting from the top to the bottom, taking in consideration that the first layer over here will be firstly laid down on the canvas, then the second and the third, and so on. Let me go and add my layers that I've imported. These ones are the default that comes with the program. I've got a bottomlet, I've got an eyeball that I want to render, the iris, the shine, the toplet, and the bottomlet are here. But I've got these extra ones, dark and gold. And the thing is, my top and bottomlet, if I look in the folder structures, I can see that they are purple. But if I look at the bottomlet gold, these ones are gold. Now, I'm first going to run this collection to show you how it looks when I run the program by just using this basic configuration. And then I'll adapt it to show you how you can make very unique kind of different races, if you want to put it like that. But in order for you to run a successful program, sometimes you only need to have one of these layer configurations. One is enough. You can make a whole 10,000 collection if you really want to from one layer configuration if you have enough folders and files inside of those folders. I'm simply going to render 10 images. So every time you make a change to the config.js file, please save this file in order for this program to pick up the new configuration. Next, what you want to do, and this is only after you have ran npm install, remember you have to install the dependencies, you can in the terminal now run the command node space index.js. When you run this command, and remember it is JS, not JX or something, it's index.js. It is this file over here, this one's name that we are basically going to run. If you press enter, you'll see that the program thinks a little bit for the first time, and then it will start off immediately creating the different layers. It's very cool to see, and if you get to this point where you can make it run for the first time, you're in a very good space to kind of create the rest of your collection successfully. Here you can see that we've created 1, 2, 3, 4, 5, all the way to 10. Now, where are these images that's being created? You'll see that it has an edition size and a DNA. This is just to inform us which ones have been created. They are now located in this new build folder. They are separated by images and its corresponding JSON. I just briefly want to show you what the metadata standards are for creating NFTs and why is it necessary. You can see that on marketplaces such as OpenSea, metadata is the information about a particular image, and this metadata can tell us things like the name, the rarity, the properties, and so forth. It looks something like this, and it's in the format of a JSON object. That's why when I say that it creates a JSON folder, each one of these images, for instance image 1, which looks pretty cool by the way, has a metadata.json1.json. This is that image's kind of information. This is automatically generated by the app for you, and you can see that it has attributes, and these are the attributes that show up on OpenSea. You notice that it's the same name as the folder and the file that it selected. For instance, eyeball was selected, and if we go to our layers, there's eyeball, the name, and white was selected. It actually takes off that hashtag for you automatically. So don't worry about the hashtag and the number being included inside of your traits. Next, it has a few different things. It has DNA. The DNA is built up by the different kind of layers that it contains in this image, and it checks that against each other to ensure that there's a uniqueness. It has a name that shows up on OpenSea, a description that also shows up, an image which points to an image location. I will show you later in the series how we upload this to IPFS and how we have to replace this image location. Then we have edition size, date, and the attributes. That's about it for our JSON files. There is one more _JSON metadata file, and this file is simply the whole collection in one. But this is usually to keep as a backup. We generally don't use it. Now let's carry on creating our collection. I can close this folder off, and every time I run node space index.js, a new build folder will be created for us. I have got a problem, like I said. I want my images to sometimes have the golden lids, but I can't really put a golden lid just inside the layer configuration over there. Let's see what will happen if I do. Let me add the gold at the end here, meaning that it would use this layer. I'm going to save it, and let me recreate this collection by running node index.js in the terminal again. After it's created my images, I see that this looks pretty cool, but it's not the desired effect, because now I've got these gold lids and they're not fitting with the purple ones. So there is a little bit of a way around this. You can go ahead and keep it as it was and create a new layer configuration. If you want to do that, you can copy everything from that curly brace to there and then paste it right below it. Keep in mind there needs to be a trailing comma between each object. Then in this one, I can decide to have the gold one over there, and I want the gold over here, meaning that I want to run a collection which is purple, which has the purple lids, and one that has the golden lids. If I do that, I can try and run it, but there will be an issue. This is some of the issues that people find that they have. They might run the program typing node index.js. Then it says, okay, cool, creating, and then starts saying, it just breaks, it stops, right? So let's change this to 5. Let me show you, let me run it again. It doesn't create the 20 that I really want to. Now it creates 5 and then undefined. It means because this is grow edition size 2. The first one should be 10. And then this one, if I want another 10 to be rendered, I need to make this 20. And so on. If I had a third one and I really wanted this collection to be maybe out of 100, then I would make this last one 100, meaning that every time it grows, so it grows first, does 10, then it grows to the next 10, which is 20, and then from 20 it will grow to 100. And that's how you do it. I'm going to remove this last one. Save your file, and let's see how we can create 20 different NFTs. So you can see that they are busy being generated, and take note that it's running in a chronological order from number 1 up to 20. If I open the images, the first ones are pretty cool, and they are all the purple ones. But as soon as I go to 11, 12, 13, and so on, you can see that they are now using the golden lids. And that's some layer configuration that you can play around with and be creative. I also want to just quickly briefly talk about the layer order. If I simply remove this eyeball and put it maybe above everything, you'll see that if I run this collection right now, and if I check inside of these files, the eyeball's on the top. So it's very important how you layer your files. Let me undo that action. One problem that I want to discuss with everyone is sometimes they find an error in the code down here. And that is usually, let's say I had a layer and I didn't put a hashtag. Let me just do that, and it's black 1. And then if I run this collection, you'll see that there's this error popping up. This error explicitly says cannot read property split of undefined. It means that you have forgotten a hashtag in front of the number. Alright, and this number is to do with your rarity. Let's talk about rarities. How can we make some attributes more rare than others? Well, it's very easy. Let me open one folder and do it to one folder structure, and then you'll see what I mean. I'm going to choose the eyeball. Let's say that I have a golden eyeball, a purple, a red, and a white one. How the rarities work is it calculates, adds these all up together. So for instance, if I had, I'm just going to cancel that, and let me actually get a calculator over here. Let's work with the calculator and work out the rarities of this eyeball layer. If all of them are 10, I can simply go 10 plus 10 plus 10, right? You add them all up like that, plus 10, which is 40. Now, 40 is the overall weight that this eyeball will carry. But the golden one would be 10 out of 40, right? And the purple one, 10 out of 40. And then red, 10 out of 40, and so on. It means that these 4 layers carry exactly the same weight, meaning that the chance of them being selected is all the same. And that's why I suggest making everything 10, and then you can go and choose which ones are your rarest ones. Let's make some of these attributes a bit more rare. I want this gold one to be very rare, so I'm going to give it the attribute number, or the rarity weight number, of 2. I also consider the purple one to be quite rare, so I'm going to make this a 5. And let's say that the white one is pretty common, and I'm going to make it 20. Now all of these carry different weights. Let's bring up the calculator again and just work it out. So you're going to say 2 plus 5 plus 10 plus 20. The total weight that this layer carries is 37. So you can see that 2 out of 37 is quite low, meaning that the chance of the golden eyeball being selected is very slim, making it way more rare. Now, why is this important? Well, if you go to OpenSea and we look at the attribute, you see that OpenSea actually gives percentages to the attributes that it carries. And that's kind of how you can roughly work it out and add these attribute weights and the rarities to your collection. I also want to show you how you can work out the actual percentage of what the golden eyeball would be out of 37. So in order to work out the golden eyeball's weight out of 100%, you can simply say 2 divided by 37, which is the cumulative sum of all these layers of the eyeball, and then that is 0.05, and then you can multiply it by 100 to get a percentage out of 100, which is 5.4%. Now that's how you kind of work out the rarities, keeping in mind that if you have different layer configurations where you include layers that's not existing in this layer configuration, your attribute might be a slight bit off because obviously you're not introducing all of the layers. This method only simply works super accurate if you have one layer configuration that contains all the layers, or if you have more than one layer configuration but they all carry the same attributes but are simply in different orders. Anyway, that being said, it is still a great way of working out how rare you want your attributes to be. A simple guide that I usually do is I open something like, let's say, the eye color, and I simply say to myself that this one looks cool because it's the rare one, and if everything is 10, then I want to make this one too. The same goes for the one here at the orange and blue and purple. I want to have this one as 2, meaning that in itself these 2 will be more rare than all of these. And there's a nice utility that you can use to work out kind of how rare these would be, but that's generally what I do. Now that you have worked out all your rarity weights and you know how rare your collection will be, Let me show you a cool trick how we can mix the collection up, because you don't want to have a collection where all your elements, if we run this again, where all your elements are from 1 to 20 and they go in chronological order, meaning that they will go and run through these layer configurations, because that is kind of predictable on what the person would mint. The utilities that I'm talking about can be found in the utils folder over here. Each one has a very unique ability. For instance, if you've ran your collection and there are some files in your build folder like so, you can in the terminal run the following command. You can say node space utils like so / meaning that we are pointing to this file, and then you can say rarity data.js. Once you have that, you can run it, and this will simply work out for each layer. You can see there's the bottom lit gold, what the chances were, and kind of what their percentages are out of 100%. Now, like I said, this doesn't accumulate to 100% because these gold layers aren't in this configuration. But if you select a layer such as the shine, you'll see that this all adds up to 100%, and this would be the true kind of chance of it occurring, because this is the actual occurrence that it's found. All right, and this is done for each one of these layers. That is a nice util to use. Another util is to create basically a preview collage. You can simply run the same command here at the bottom, utils / but this time run create preview collage, and if you hit enter, you'll see that in your builds directory, a preview image is created for you of the existing images that was created. Keep in mind, these utils can only be called after you have created a collection. Seeing that I'm busy with utils, let me explain another utility. Let's say you have deleted for some reason the main _ metadata file. Now, this will not work if you've deleted any of the other ones, only if you've deleted the main one, which I'm not sure what the use case might be, but it is there. What you can run is node / regenerate metadata file, and what it will do is it will calculate all of these and regenerate that main one for you. This can be handy if that's accidentally deleted. I don't know if you guys can hear the storm in the background, but in show business, the show must go on, right? So let's carry on and look at the final and most important utility function. It's called the update base URI. Now, it has to do with the metadata files. So if you look at all these metadata files, and imagine there are thousands of them now. We have created thousands of artworks. Well, you will see that each one has an image attribute, and it is appended with the edition number at the end .png. So you can see each one is different with the different edition number. Well, we need to sometimes change what this points to, because this needs to point to some kind of place on IPFS. How do we change all of these files? Well, there's a utility that we can use for that. How you use it is you go to the config.js file, and if you want to update the base URI, let's just do this, update without a /, okay? So we're going to put it in just like so, and then you save the file. Down here in your console, you can now run node space utils / update base URI. Once you do that, you'll notice that all of our JSON files now have this new update as the image base URI. Plus, it also has the basically the image files. You have to make sure in the config.js not to include that /, that trailing /, because it's automatically added once it's here in your JSON file. You cannot have two / here at the end. It is okay here at the front, but not at the end, okay? That is a mistake that a lot of people make, and I just wanted to clarify that. So these are the utility features. They do absolutely nothing to your collection. They're just there to help you out. Now let's carry on and make this collection super cool. So carrying on with the collection, we need to make sure that our description here is replaced. Our description is the description that will show up on OpenSea. So make sure that you have replaced this line with your own description. I say here, remember to replace this. So let's just type something in. Let me say the coolest NFTs, right? The coolest NFTs, that's my description, but you can make a long description if you want to. I'm going to leave the base as is because we will update this once we upload to IPFS. Next, make sure all of your layer configurations and everything is running successfully. If you run node space index.js and your collection runs successfully like this, you know that you have done this correctly. So just play around until you get it right and that your collection runs successfully. If you get stuck, like I said, head over to the Discord community. They will help you out. All right. Now, like I mentioned, we have a problem. All of these ones are in chronological order, so this is the order that they will get minted in. But what if I want to mix a bit of these golden eyes in between the purple ones? I don't want all of them to be in a chronological order, because what if you have alien races, zombie races, and so on? You might want them to be mixed up. You can do that. So in the config.js file, if you scroll a bit down, there's this attribute called shuffle layer configurations, and you can simply turn this to true. Once you do that and you save your file and you run the collection again by running node space index.js, you'll notice that it renders in a random format. So it first rendered 3, 20, 19, 17 down here, and so on till it's done. Now you'll see that they pretty mixed up, and that's awesome. A way that you can add rarity into this is by saying, let's use a lower number, and I'm just using lower numbers to test. You can use as big as numbers as you want to. You can use thousands of images that you want to output. But let me say I wanted to create 10 of these and only 2 golden ones. I'm going to then make this 12 because I want to add only 2 to the 10, and then I want to render it. This way I even create rarities within the folders themselves, well, within the layer configurations themselves. So only 2 will be gold, and there they are. And that way you can hype up a community by maybe making sure or telling them that there's a rare golden one or a rare special NFT in your collection. So carrying on through the config.js, like I said, there's a few extra things that you can play around with. One is the debug logs. If you turn this to true and you run your collection again, you simply get more information on your collection's rendering. This is sometimes useful if you just want to see everything working, look at the DNA, look at the metadata as it's being outputted. But it's generally not necessary to have this to true, so it's by default false. Your output size, you can change to whatever you want to have it. You can make a width if you want to have portrait, landscape. I always work in squares, but you can make it any size you want to. We can make a bit of a bigger images as well. Just remember to save the config.js file every time you make a change. So there I'm rendering a bit bigger images. So now you can see they will be bigger and higher quality. Next, a lot of people ask what this background is. Well, let's say I didn't have backgrounds at all, which is in my case simply, if I look at my layers, it's simply a black image. But let's say I didn't have them, so I removed them out of my layer configurations and I turn this background to true. This simply generates a random pastel color which you can set the brightness and the hue of by changing this parameter. So if that's set to true, it will always create a random color as a base image. So if I open the images now, you can see that there's a blue background. This one is green, this one is blue, purple, green, and so on. Okay, orange and it just carries on yellow. All right, and that's basically what that attribute does. It's mainly for people who don't have background images and wants to just simply render them out like that. I don't really want this to render, but I'm going to leave it on as true anyway. It won't make a difference seeing that I have a background layer that covers it all before it starts. Then you can basically go and add extra metadata. If I had extra metadata to add, such as the artist, so I can write artist, and artist was Daniel, right? I can also say maybe I want a surname which is my surname. All right, let's just say for some reason I want this. I can save this file and then run node index.js again, and then when I look at my JSON files, these two attributes will be added on each one of these files. So keep in mind this will be added to each one of these files, and you have to have it in a format of a key and a value pair. The key is always generally good to have in lowercase. That is an extra option that you can include. I don't really need that. Then we have the rarity delimiter. That is basically to do with, if you look at your layers, if you want a different delimiter, so if you don't want a hashtag and then your rarity weight, you can change it over here. I generally leave it as a hashtag as well. Then the unique DNA tolerance, this is basically just set for your program to fail if you don't have enough layers to create enough images. For instance, if I didn't have enough layers at all to complete a cool collection like so, and I save it and I run this program, it will soon run out of DNA exist, and if there's 1,000 DNA exists, like so, it will throw an error saying that you need more layers to grow to this 10 artworks. Okay, that's basically what this is. It's the tolerance of how many layers it can find and then replace, find and replace. And if there's 1,000 of these occurrences, it means that you probably don't have enough layers. Let me undo this action. Perfect. Then the preview is basically to do with the preview set that you've seen in the utility. So you don't really have to change these things at all. The only thing that you really need to worry about are the layer configurations. Like I said, make sure that you're happy with your collection, and then once you are happy, you can go ahead and render it. So the most important part is your description, your base URI, but that we change afterwards, and then your layer configurations, how many you want to create. So let's say I wanted to create a simple collection. I also have the dark lids over here, so I want to include that as well. So I'm going to start off by having one layer configuration, which is the normal one. Then I have got one with the dark lids. So I'm going to have the dark like so. And then I'm going to have the golden ones. So let's say I want a collection that consists out of 50. I'm going to grow the first collection to, let's say, maybe 25. 25 is fine. Then this one, I want to grow maybe to 45. And then lastly, I only want about 5 of the golden ones, so I need to make it 50 to end my collection at 50, meaning that this will be 5 and 25, and then you minus 25 from this, which is 20 of these ones, and then 5 of the golden ones. And that's basically how you can set up layer configurations. But like I mentioned, most collections only consist of one, and you can put this to maybe 5,000 images and render it. Okay, I'm going to undo that because I want these different configurations. I am happy with my collection, and I hope you guys came right with this program, because at this point we are ready to move on to the next step. All we need to do now is go to the terminal and for the last time place node space index.js. This is our final render, and at this point you can be proud of yourself because you've achieved finally rendering multiple different artworks from your layers. So once this is done, we're going to go ahead and upload it to IPFS. For our next step, we need to upload our NFTs to some place where it's hosted. Now, IPFS is a great hosting service which is decentralized. There are many ways of uploading data to IPFS, and using a service such as Pinata is a great tool to use. Now, you can go into pricing, and then you can see that it starts from a zero plan, which allows you up to 1 GB of storage, which is more than enough for my use case. But even if you have more, their plans are extremely cheap and it's there forever. So go and subscribe or just use the free plan. But once you have, you'll get to a dashboard looking like this. Here you can see that I've already uploaded the Nerdy Coder Clones collections, and they are on Pinata and on IPFS and will live forever. Now let's go ahead and upload the data that we've just created. If we look in our DApp that we have in the build folder, we've got all of our images in here, and we also have all of our JSON files. We cannot upload the JSON files at the moment, and I'll explain why. But you can go ahead and upload all the images so long, because we need a CID from Pinata to tell us the unique folder that it's going to live in. Let me explain. Now simply click on Upload Folder and click on the folder that we've created in our build file, Images. We want to upload the whole folder like so. Once you say upload, you can give it a name. At this stage, it's good to call it the collection name that you're going to host it as. It's just basically a reference. It doesn't have to be anything fancy. But I'm just going to refer to this as eyes, and let's call it images, like so. So these are my eye images, and it's going to upload them. Once this is done uploading, what you want to do is copy the unique CID, and then we're going to update all the metadata. Let me wait for this to upload, and I'll show you what I'm talking about. And there we go. All of our images have now been uploaded, and this is our unique CID. It's identified by starting with a QM. And you can go and view this data if you click on that eye icon, and it will simply load the IPFS through a gateway. And the gateway that it's choosing is this Pinata Cloud IPFS. But this is actually where your data is located. So in theory, when you render your metadata from the contract, or when your contract returns metadata, in theory you want it to point to something like 1.png. And this will actually show us that image. And this is the metadata that we want to save. So that's why you need to copy this CID. If we briefly go and have a look at the metadata structure that OpenSea provides for us, you can see that they prefer that we give it a format such as this. It doesn't have the gateway in the front over here. For instance, here you can see this is the gateway, everything from here to there. But if we see OpenSea's documentation, they just want us to put this and then our CID to the folder, and then they will find it for us. They will basically show the NFT metadata to us. Well, the image in that case, because remember, we now only have uploaded our images. But let's go ahead and copy this, and I'll show you what I mean by changing the metadata. We now have to go back to our program. And remember what I said, go to your config.js and replace this update part. It still needs the IPFS : / and then that CID, okay, with no / at the end. Once you have this, save your file, go down, and please do not run node index.js at this point. What you want to run is node utils update base URI. Once you've done that, like I said, it updates all the JSON files to have these extensions. So now you can see if I copy everything here to there, it includes the / 5 because it's now pointing to number 5. So we can verify that by replacing everything from here to the QM. If we run this, we can see that we get a different image, and that's what we want. So now that we have that, go back to Pinata and then click on upload again, upload folder, select a folder, but this time we're going to select all the metadata, so the JSON, like so. Click on update or upload, and then you'll see it needs a new name. So this time we're also going to say I, but how about we say metadata? Now this will take quick, it's just a few files, and once all of those files are on, now we actually do have the CID that we are going to link to the contract later on. It will pop up here once it's uploaded, so I'm just going to maybe hit refresh and let's see. But basically we have completed our first part. Now there we go, there's the metadata. So in essence, if we look at the documentation again, OpenSea wants us to return this metadata for it. And how do we achieve that? Well, because we have the metadata, we can now click on this icon, and then once it's loaded through the gateway, let's look at number 30. If we look at number 30, well, we have to say 30.json. If we look at number 30.json, we can see this is the metadata. And indeed, there is our IPFS link, like OpenSea wants us to point to the image. Even though the JSON is its own IPFS link, this points to the image alone. And that's all you need to do. Now, a lot of the NFT projects have hidden images. How do we accommodate for that? Well, that's pretty simple. What do I mean by saying hidden? Well, a lot of NFT projects kind of reveal the images only after the pre-sale or some kind of sale has ended. And that's when you can reveal the images, the real metadata, and that kind of creates some kind of excitement. How can we achieve that as well? Well, we have our real metadata and images up already. So now it's time to kind of emulate one that's hidden. So what you can do, maybe open up the Minter that we were busy with, the build folder. Let's go and copy a JSON file, anyone will be good. And we need an image. Now, I do have an image over there. It's called hidden, so I'm just going to drop this in there as well. And I'm going to make a folder for each one. I'm going to say, this is going to be the hidden image. And I'm also going to say, yeah, hidden is probably a good name for this. So this is the hidden metadata. All right. Now you can drop your hidden image. It looks like this inside the hidden image folder. And then for our JSON, I'm just going to rename this as hidden as well. Okay. And then drop that in our hidden metadata file. Now I'm going to open the hidden.json file. And I'm going to get rid of all these attributes. It doesn't need these attributes. So I'm going to remove that. And I'm going to remove the date, the edition, the image I'm going to leave, the description I can leave, right? And the DNA can go. So I only need really these attributes. We also don't need the compiler. So this is all that we really need. Here I'm going to write this image is hidden, right? And then we are going to change this once we know what that image URL is. So I'm just going to save this for now. I'm going to keep this file open, okay? Then let's go to Pinata. I keep on saying Pinata. I don't know how to say it. Is it Pinata? Perfect. Go and hit and click upload folder, select, and now the folder that we want to select is this hidden image folder. Say upload, and this time I'm going to say I_hidden_image. Okay. Going to upload it like that. And then once this is uploaded, once this has refreshed, I'll be able to copy that CID. Make sure it's the hidden image that you've uploaded, CID. So then I can go back and populate this. But this time I need to say hidden.png. And to test this out, you first copy this. Okay, everything from the queue to that part. You copy this and you go back and you click on this eye icon and you go and replace everything. Once you have the gateway here, just replace it and call it. And there you can see we do get that image. So our metadata is pointing to the correct endpoint. So save this metadata file. Now you can go back to Pinata and upload another folder. This time it's going to be our hidden metadata folder. So it's going to be hidden metadata. We're going to call it I, hidden, and then metadata. And once that is done, we are all set up and ready to rock. We've got a few uploads. We've got the metadata and their corresponding images. And that's all we need. And now we can have a look at the next step in the process. I want to show you what you can do if you have made a mistake. So let's say you are testing your hidden metadata JSON, and for some reason you go there and you see that you have your URI/hidden.json, right? And you see that everything is perfect, but the name is still that. You don't want it to be #1. Well, there's a simple way that you can fix this. You can simply go ahead and click on More, and you can delete the file. Now, deleting that file will remove it, and if it hasn't been on long enough and pinned, it won't be shared to all the different nodes. So that's perfectly fine. So we can go back to where we want to change that. We can make an update, and we can just say this is the purple eyes, right? Let's do it like this. The purple eye. Save that. Go and do the same process again. And because this CID is the same for the hidden image, you can simply just upload that folder again. This is something people didn't understand, and when they made mistakes, they panicked and they didn't know what to do. You can just simply follow the same step. All right, I'm going to upload this again. And then once we have that hidden metadata, we can go and view it again and then append it with the hidden.json, and we can see it's now fixed. That's just something I wanted you to test, and it's also a good idea to always test the endpoints before you upload them to the contract. Now for the next part. In this part, we will focus on deploying the contract to the blockchain. It's very simple to do, and all you have to do is open up Visual Studio Code again, then say open and find the place where you have downloaded the Hashtabs NFT contract. Open this folder, and in this folder you'll see there's another folder called contract, and the contract that we are going to be focusing on is the NFT, the simple NFT _flat. Now, the flat part means that all the dependencies have been imported into this big contract. The actual contract that we are going to work with is here at the very bottom. But there's also a copy of it over here. You'll see that it's a simple contract that has a few parameters that we are going to play around with, and then it has a minting function which only takes in one parameter that allows you to mint how many NFTs you specify. At the end of it all, you can then also withdraw the ether after a lot of people have minted, set up a bunch of parameter changes with the only owner modifier selected, and there's a bunch of stuff that you can do with this. It's a very simple smart contract, but it does have the revealed functionality in it. let me show you how you can make use of this contract and where you can deploy it. Now, there are numerous ways of deploying smart contracts, but a simple and effective way is using Remix, which is an online Solidity compiler, and by using MetaMask, you can deploy to test networks and main networks easily. The first thing that you want to do is select the NFT, the simple NFT underscore flat.sol. Copy all the contents in this file. After you have copied it, you can go to your browser and type in remix.ethereum.org. Once you're on Remix, you'll see that this is the starting screen. What you can go ahead and do is click on this plus icon over there, and let's call it the I, right? I'm just going to call it I. This is my workspace. Remix gives us these three files, which really are only starter files. It is mini smart contracts that they give to us as examples. And you see if you click on them, it starts creating artifacts. Just go ahead and remove everything. So after you've removed everything, you can just close all these folders and your contract should be empty. Next, right click and create a new file. This file is going to be our final NFT. So I'm going to call it I. I'm just going to call this I, right? There might be numerous I's out there. So maybe let me call it purple I. By convention, it's good to start with a capital letter and use Pascal case for creating the smart contract name. So purple I, where purple is capitalized and I is capitalized too. This is now our smart contract file. What we can do now is paste all of the content that we have copied from our contract. You'll see that a lot of artifacts get created. This is because all the dependencies have now been created in this one single file. Everything is in here. If you scroll to the very bottom, you'll see that starting from line, let me just go a bit up, starting from line 1, 2, 3, 5 is our smart contract. It's just called NFT. This is the very first thing that we are going to change. So if you are not used to Remix yet, maybe go and watch other tutorials where I'm working with Remix, where I have much more extensive explanations on Remix as a whole. I'm just going to show you the brief explanation of how to change the necessary things to have a successful collection launch. Go ahead and make the necessary changes. Starting with the name, I think we can change the name of the contract to Purple Eye, and it's also good convention to call the contract the same as what it's called in the file. So I'm going to stick with Purple Eye. Then in this section over here, these variables, this is kind of mostly where you need to update and customize this NFT contract to your needs. For instance, I do not have to touch the base URI, this base extension really, and the cost I do need to change. So cost is basically how much it's going to be for someone to mint one of your NFTs. Now, keep in mind that we will be deploying on Polygon and Ethereum. So we would probably change the cost because the value of these two currencies are very different. But Ether will stay the same. Ether is simply a nicer way of appending a million zeros to convert Ether to Wei, okay? But Ether basically just makes it a nice readable way for us to write how much Ether this is going to be. I'm going to say that my eyes are going to be 0.0241. So I'm going to make that the price in Ether. And if I deploy on Polygon, which we will do, it's going to probably be a little bit higher. I'll probably make it like 5 Polygon, but we'll get there. So I'm going to leave this at 0.02, and we have minted 50 NFTs. If we go back to Pinata, we can see that in our metadata, if we go and open this eye, we have only 50 NFTs that's listed in here. They're not listed in order, but there's about 50 of them. So obviously I want to keep my collection to 50. So this is the max supply, which I'll change to 50. Now, if you have a big collection, like obviously 50 is a quite small collection, this max mint amount. This max mint is the maximum amount that a person can mint per session. For instance, if they call the mint function, they can mint up to 20 NFTs if it's left at 20. But seeing that I only have a max supply of 50, I'm going to say people can mint a maximum of 2. That sounds reasonable. Now, this paused variable determines if your contract is paused. If a contract is paused, not the owner or anyone else can mint. But if someone has already minted, they can freely still use the contract, send the NFTs around because it's their NFT. It simply just pauses the minting functionality. Usually you would start off by having pause set to true. And the reason for that is because you might want to deploy your contract and only set it to true once you have maybe made the announcement that everyone can start minting. So maybe a good idea is to set this to true from the start. Then, should it be revealed? Now, revealed should be false because we want to first display our hidden image, and then later on, once the collection is sold out, we will then reveal all of our NFTs to the world. Okay, and then we have the not revealed URI, which stays like that. That's all we have to change. So once these changes have been made, you should see this green tick here on the Solidity compiler section. By the way, how Solidity works is it has a file system where all your files lives, a Solidity compiler section which has all the compiler details. A good rule of thumb for me is always to put on enable optimization over here. Then we also get the deploy and run transaction section. All right, perfect. But let's go quickly to the Solidity compiler section. Something that you need to make sure of is this pragma line. Just make sure that your Solidity compiler is in between these two specified versions of the compiler, and indeed it is. It also will select it automatically. If your contract doesn't compile yet, if it doesn't do it automatically, you can tick on the automatic compile and it will do it every time there's a change in your smart contract. Once you are happy with all your parameters that you've set up, go to the deploy and run transaction section. You can find it here on this Ethereum looking icon. The environments that Remix provides us is in browser blockchains. These are the virtual machines. These are great for testing. So if you want to test these smart contracts, you just select one of these and then you go ahead and do exactly the same. And this won't deploy to a real blockchain. Instead, it will deploy to the browser blockchain. But seeing that this is how to deploy on the testnet and then onto the main network, we have to follow the injected Web3 provider one, like this one, okay? So make sure that you are on the injected Web3. Now, this is where you need to pay attention. Currently, it says that you are on the main one network. This is the Ethereum main network. If you try and deploy now your smart contract, it's going to try and deploy on the real main network. So, in order to avoid that, go to your MetaMask and go and switch the network over here on your RPC. If you click here and let's select a different network. Now the Rinkeby and the Gurley and all these other networks are test networks. Let's select the Rinkeby network. If we've selected the Rinkeby network, you can see that I've got some test ether in here. You can get test ether from a faucet. There's numerous videos on that. But I can now be sure that I'm on the Rinkeby test network and also see that over here, it says Rinkeby network 4, which is great. When I deploy to the Rinkeby test network, this will actually deploy onto the Ethereum network and we can test it on the test OpenSea, which is perfect for our use case because we want to do that to test that everything is functioning before we deploy on the main network, which is network number 1. On a side note, A lot of people have asked me how can they deploy this smart contract on Polygon? Well, that's very simple. Again, you'll go to MetaMask and select which network you want to deploy it to. I do not have the Polygon test network, but I do have the Polygon main network here. All you have to do to get the Polygon main network on your MetaMask is Google RPC Polygon main network, and it will give you the details to set up this RPC. But once you're on that, you'll see that the custom network ID is 137. Keep this in mind because I'll show you this later on in the video when we create the dApp. Anyway, let's get going and let's actually deploy on the Rinkeby test network. So I'm going to go to MetaMask. I'm going to go to Rinkeby test network, and you'll need some test ether for this. If you don't have test ether yet, you can simply test stuff out on the virtual JavaScript virtual machine, but then it won't show up on OpenSea because it's not really on a hosted test network like Rinkeby is. So let's go and test this out. What you can do is you can go down on the deploy section. You don't really have to change any of these. You have to make sure that you have some test ether in there. And then you can go and select your smart contract. So make sure that in this contract section, you have selected your smart contract. If you select anything else, you'll be deploying a different smart contract. These are all the dependencies that our one has. Once you have done that, you'll see there's a deploy section where we now have to fill in a bunch of details for us to deploy this. So to make it easy to fill in all these details, you can click on this drop down arrow. You'll see that it gives us a list of things to fill in. I've just placed a lot of T's in there. But the first variable is the name, and you can see that in our constructor function. By the way, a constructor is a function that only runs once, and once the contract is deployed, it will never run again. So on startup, we pass it a name, a symbol, an initial base URI, and the initial not revealed URI. All right. How do we get these details, and how do we actually fill these in? Well, let's think of a cool name for our contract. We want to call this the purple eye, right? So we're going to call this purple eye. Our symbol is going to be PE, and this is just an abbreviation of purple eye. Then we need the initial base URI. Now, we need to go back to Pinata. And I also want to show you that on OpenSea's metadata standards, remember what they said, they want the format like this. So you can go ahead and first type in IPFS : //. I'm going to simply copy this because at this point we don't want to make mistakes. Even though this is the test network, we need to act as if it's the real one. So go and paste in IPFS : //. Okay, then go to Pinata. Once we're in Pinata, this is going to be, this URL is the actual metadata, the real metadata URL. So I'm going to click on I_metadata. This is not the hidden one. Open it up. And then once I'm here, I need to basically copy all of this. But this is now where there's an important thing to remember. You need to have a / when you deploy the smart contract over there. So at the end, add your /. Please remember that. Add the /. I'm going to say it again, add the / because 99.9% everyone forgets that. So add the / at the end and then copy everything up to the QM. Then yours might look different, obviously. Then go back to Remix. And then after this IPFS : //, you paste what you've just copied. So your URI would look something like this. I'm going to go back to where we were, and I'm just going to paste it in there. So your IPFS will look, your URL that you put in there will look exactly like this. So make sure that it looks like this. Obviously, your CID would be different, but the format should stay the same. Let's go back into Remix. Now we need to provide it the actual hidden URI metadata. So let's go back to Pinata and let's go find the I_hidden metadata. Click on the I icon and let's do exactly the same. So I'm going to wait for it to load, and while I'm doing that, I'm going to head back to the OpenSea documentation, make sure that I copy the IPFS://. The only reason why I'm copying it always is to make sure that I don't make mistakes. You don't want to make mistakes. Of course, you can update it using the update functions that I've placed in the smart contract, but it's unnecessary to use them after a smart contract has been deployed. But it can be rectified. Anyway, let's go and see if this has loaded up. So there it is. I'm going to copy everything from the QM, but before I do that, I need to put a / and this time say hidden.json, like so. I need to now copy everything from hidden.json because this from everything from the end, hidden.json included, up until the QM. This is only for the hidden metadata. So you're going to paste it after the IPFS://. You're going to paste it there, and it has to have all of that data in there, including the / hidden.json. The top one doesn't have that, it just has the /. I hope that is very clear. All right. Next, what you need to do, and this is super important. I cannot stress how important this is, this next step. Before you forget, go and click on this little button, and this is after you filled in the details exactly as you are going to deploy this contract. Before you click on transact, you click on this little icon which copies the bytecode. Now you can go back to Visual Studio, maybe create a new folder and call this info. I'm going to create a folder and call it info, and then I'm going to create two files. I'm going to create a polygon.txt, and I'm also going to create a new file, and I'm just going to call it ethereum.txt. I don't think txt works on Mac, so I'm just going to call it Ethereum, and I'm going to rename this to just that. So it can just be a text file. But seeing that this is the Ethereum test network, right? Because these are test networks, so maybe it's a good idea to append test because it's not the main one. I'm going to put this there. I'm going to paste everything that I've just copied. Now, once you've saved this, I think when you close the file and open it again, it would have rearranged all the bytecode for you like so. Just have this saved, because this is needed when you need to verify your contract. Okay, perfect. Let's now go back to the browser where Remix is waiting and ready for us to deploy. Once you've copied that, you can now freely press transact. Make sure that you are on the Rinkeby test network. You can verify that, like I said, on MetaMask here at the top, as well as that you have some test ether. This is not real Ethereum. This is, you can get this from a faucet. There's a lot of videos on that, like I said. Once you are sure everything is correct, you can hit transact on this button. It's going to ask you to do a transaction, and this is emulating what will happen if you deploy on the real main network. So just hit confirm, and just a side note, please review the code before you deploy your own smart contracts. And then you can see after the contract has been mined on the blockchain, you'll see it pop up here at the bottom. You can expand this, and at this point it's a very good idea to kind of look at all these functions that the smart contract provides. There are a lot of smart contract features and functions, but the main one is this mint feature. I can now go ahead and, as the owner, because I'm on the owner's address over here, I can now go ahead and try and mint. The function will not work if I try and mint one. Why? If I say transact, it says this transaction might fail. And the reason for that is because our smart contract is still paused. You can check the status of your smart contract by clicking on some of these blue buttons. You can see that our base extension is JSON, our cost is that much in way, and then we can also see the max apply, we can see the max mint amount at each given time, the name, the not revealed URI, which is the hidden one. We can also see who's the owner of the smart contract, if it's paused or not, and indeed it is. And then you can see if it's revealed or not. It's still false, and you can also see the symbol. These blue buttons are basically call functions. So they don't cost any Ethereum or gas. They do cost a little bit of gas, but you don't pay it. But it's basically just reading from the smart contract. As we can see, we have a paused contract. So how do we unpause it? Well, there is a actual function that we need to use, and this is now a transaction, a send function, where we need to transact. So in this pause function, you can now open up your contract. So let's say pause is now going to be false. If I type false and I click on pause, it's going to ask us to do a MetaMask confirmation. And once I do, it's going to mint on the blockchain saying that we need to change the status from paused to false. If I now try and transact and I click transact, you can see that it's trying to mint. It's going to tell me the gas that it wants me to use. I'm going to confirm it, and then it will actually mint one on my address that I have specified over here. After the transaction is successful, let's just wait for it over there. We can also keep track of it if we go to MetaMask and see there is the mint and it's being minted. Keep in mind that this is all happening on the test network, but it is really on the test network, and I'll show you now that it shows up on OpenSea. We've got a successful mint. So now I can see if I click on total supply on the call functions that it's 1. I can go ahead and actually try and mint on someone else's address as well. Let me see if I have an account that has more test Ether. This one also has some test Ethereum. So I can go ahead and connect it, and this will change. And then I can also go and try and mint one over here. So instead of trying to mint 1, I'm going to try and mint 3, just to show you that because we've set our maximum mint amount to 2, if I try and transact, it's going to tell me it's going to fail. This won't happen in the real world. It will fail. But Remix is nice enough to let us know. So let me try and mint 2 at a time. I can transact, and it says the gas estimation error occurred, because it can't really estimate how much gas it's going to need to actually complete a successful mint. And that's these days a problem, that you need to kind of specify the amount of gas that you need to put through, but also have the correct parameters. So what are the reasons why this would fail? Well, if you see here, it requires, if a person is not the owner, that they need to pay for it. And we know that we need to give it some way with Ethereum, right, into the smart contract to mint one NFT. And one NFT costs us 0.02 Ethereum. So how much way is that? Well, we can go down and see the cost in way over there. So I'm going to copy this cost. I'm going to go up and put it here in the value parameter. Once I've done that, this is for one NFT. So I will be able to mint 1, but not 2. So I need to kind of up the value to maybe 4, just so that I can mint 2. So once I've done this, I can say transact, and there you see it's now going and making a transaction, sending 0.04. If I confirm this, it would start minting my NFT. Now that we have successfully minted another 2, we can go and double check it on the total supply. It should now be 3. So if you click on total supply, it should be 3. You can also take the address that you've now used to mint these and place it in functions such as the wallet of the owner And if we do that, so let's go and get this address that we minted with. If we do that, we can see that this owner now owns the ID number 2 and 3. We can also add whichever token ID we want to, and we can get returned our token URI. This is the URI that OpenSea uses to go and grab the metadata, and here you can see it's still hidden because our contract is not revealed yet. I'm sorry for the thunder in the back, but it's beautiful. I love the nature, so we're just going to keep on going with the tutorial. I hope you guys can still clearly hear me. Anyway, we also got some interesting functions on our smart contract, such as the token of owner by index. This is an array of the token owner's personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address and put 0, it would be 1 because that's their array, right? Then we have token by index. So if we query token index by 0, this should be 1. If we do 1, it should be 2. This is just how it works. It runs 1 ahead because we start minting from 1. Then we also have this function which is to do with the standards of the contract and the owner of the token ID. So if I say who's the owner of token ID 3, then I can see that it's this address that we've minted it from. And there are numerous of cool features that you can play around with. We can also check the balance, and you can see the balance is 2 of this address and so forth. Then some of the more complex features of this contract, but very cool, is you can actually set a new cost, a new base URI, a new base extension. You can safe transfer your NFT to someone else. Then you can also reveal the smart contract by just clicking on it. And a very dangerous button is the renounce ownership. Do not click on that if you do not really want to give the ownership away. Then you have this pause that we have tried, and obviously the mint and approve. Approval basically just approves someone else or another contract in order for them to interact with that NFT. And that's usually why you see a lot of approvals when you interact with OpenSea. Lastly, we get the withdraw button. Now, as you know, we have sent some ether to this contract when we minted with this last person. Let's go and try and call withdraw, but let's stay on this person's address and see what happens. It's going to fail. And the reason for that is because we are not on the original owner's account. Let me switch back to the original owner and then call this. Before I call this, I want to verify how much ether I have in my account. And this is 9.51. If I click withdraw, it's going to kick off a transaction. And once it's successful, we should see the total 9.51 change. And indeed it did. And I withdrew all the funds from this contract that people have paid to mint, right? And you can call this over and over and over again. Something very important to do at this stage is to, at the top here, copy your contract address by clicking on that copy button. Head over back to our Visual Studio, and because we have this file that we've created, let's add a few spaces and put our contract address in there for our test contract. This is the contract address that we can find on the test network scanner, right? This is just information you want to keep, and I'll show you the reasons why in a second. But if we go back, you now see that this is your control panel to work with your smart contract that's live on the actual blockchain. Although this is the Rinkeby test network, we can still see that this is live and it's interacting with the smart contract that's existing on this blockchain. Now, in order to see our work, we can head over to OpenSea. Well, not the real OpenSea. The real OpenSea will only show your artworks in your collection if you have deployed to the network with ID 1, with a real main network. And therefore, because we have deployed on the Rinkeby test network, not the top one here, the main network, which will cost us real Ethereum, we can still test it on OpenSea, but we have to go to the test net. So we have to type in test network. So you also will see OpenSea will actually kind of suggest it over here. So I'm just going to click on it over there. And the test network URL looks like this. So once we're on the test network, we can go ahead and go to our profile like normal, and we will actually see, big reveal, there's actually the Purple Eye collection is live. Now, because you own this collection, you can actually go to this collection yourself, and on the Purple Eye collection, you can click on it, and you'll see there should be 3 items, because remember, I minted one, and then on another address, I minted another 2. So there they are, and they're not revealed yet. And you can go and edit your collection. If you want to put a new image over there and a background image, you can click on the edit button at the top, edit your collection, and you can go and fill in all these details. Something important is that you can set the percentage of your royalty fee here. So you can maybe set it to 2.5. And then you set a wallet address that you want this to be paid to. Now that's all, and you can hit submit and update. But because this is on the test network, I feel there's no need of doing this. Simply we want to test our smart contracts, and then once we're happy, you deploy to the proper network. If you are happy with your smart contract and it's working fine, you will then go the step further and go and deploy it on the real main network. But we haven't stopped testing our smart contract. Let's say our sale has ended and we want to reveal the smart contract. We want to reveal these images. Well, let's click on the collection and just have it open like this. Let's go back to the Remix control panel. And if you haven't closed this yet, you can still work with it on your browser. You can keep this open for as long as you want. I will show you a way, however, to get this back if you accidentally close down Remix. Alright, so next we can also see that if we click on this reveal button, making sure that we are on the owner's account, we can say confirm. And once we have done this, it will take a transaction, and once the transaction is complete, then our collection will be revealed on OpenSea. Let's wait for this transaction to finish. We can see that it might take a few seconds. There it is, it completed, reveal. And if we go back to OpenSea now and we refresh this page, we can see that if we go down below, it's not refreshed the metadata yet. And if that happens, all you need to do is go onto your collection and click on refresh metadata up here. This tells OpenSea that there's new metadata that it needs to pull in, and it will go and do so. And then once you get back to this image, it will actually show up. If you have bigger collections, it's better to go and call OpenSea. Otherwise, you can just tell the community to hit refresh metadata. That's why this button is there. Users can also freeze their metadata and do whatever they want to. But let's refresh and see if it actually pulled in. We can see that it's not there yet. We can, however, go to Remix, and inside of this function, or on this function token URI, if we call it again, I'm not going to change the parameters. This hidden should change to the proper URI, and indeed it does. So we can expect this to work. We can also just verify and test this by copying what is being returned and pasting it in our Pinata test case that we've used. So we can see if we call this, there's our metadata. So OpenSea will update this as soon as you have clicked refresh. Let's give it a second or so. While we are waiting for this to update the metadata and for them to reveal the NFT data, I'm just going to hit refresh again. And on this one over there, also maybe going to hit refresh metadata. It says this item is queued and will update in a minute or so. Once we are waiting for, while we are waiting basically, let me just go back to Remix and show you what you have to change to deploy this on the main network. You basically have to change nothing. All you'll need to do is change your MetaMask and where it's pointing to. So once you're happy with everything, you have tested it, you can simply go to the Ethereum main network like so. Make sure you have some Ethereum in there. And then once you have these already filled in, if you change something in the contract, it's going to go away. You need to redo this and you need to recopy everything like I showed you. But if we hit transact, it's going to say that this is going to be the cost. And if I say confirm, it's going to say this is going to cost me $414 plus the gas. So then you can hit confirm. There's no funds in this account, so I can't do this, but I will show you how I can deploy on the Polygon network. So let me go and show you how I can deploy on the Polygon network and actually follow the verification steps as well. Now, let's just double check on OpenSea. Maybe they've updated it. So, oh, I have to be on the Rinkeby test network though. Let's go Rinkeby. Perfect. Now you can see that the metadata actually has updated. And how can I see that? Well, it now says #1, which is the actual name of this NFT. We can also see that it says the coolest NFTs, meaning that it is pulling in the right metadata. It's just not refreshing the image. So that might take some time, but give it some time for the metadata to pull it in. If you are really stressed about it, you can always verify it. Like I said, you can always go ahead and test it out. So if you want to go to your remix again and you want to say owner of token URI, you can go and duplicate all of this up until the QM, go and find that Pinata link, just try it out like so. And then you can basically double check and make sure that this says IPFS : and then you simply replace that here at the top, like so. Once you've done that, the image shows up, and how lucky are we? This is actually a golden one. You are quite assured that this will update, okay? So just give OpenSea its time to do that. Now, we can also see that this one still says purple Ike, and this one says #2, #1, and this one still needs to, update the metadata. But let's go ahead and deploy on Polygon, because a lot of people have asked me, how do I deploy on the real Polygon network as well? Just so by the way, as soon as I went back to OpenSea, it's now pulled in the images as well. And now you can see that they are revealed. And how cool is that? So let's get going. Let's do the Polygon version this time. So all you need to do is go back to Remix, okay? And we can actually now get rid of this smart contract. But this is not the flow that I usually follow. I never get rid of a smart contract before I verify it. But seeing that this is on the test network, I really do not care about this smart contract. I usually do the following steps only for the mainnet contract. Okay, so this is the real deal. This is where we either deploy to Polygon or Ethereum, and each one will work. And the reason why I say that is because I just proved that I deployed on the Rinkeby test network for Ethereum. I'm not going to deploy to the real Ethereum network. That is very expensive to just make a tutorial on, and I don't want to put messy content on that network, right? But Polygon is affordable enough, and I can really dive into doing it on the real network and test it out and actually show you guys how to do it properly on Polygon and Ethereum. But all you have to do, and the only change you need to do both for Ethereum mainnet and Polygon mainnet, is simply go to your MetaMask. Go and make sure that you're on the network that you want to deploy to. So if it's Ethereum, you'll select Ethereum. You'll go and make sure all these details are correct, the correct contract. All these things are in there as it should be. you copy the encoded bytecode and you transact. And then you go and confirm, and you pay the gas fees and everything that you want to deploy for. This is quite high. But anyway, that's how you deploy on the Polygon mainnet, on the Ethereum mainnet, sorry. When we get to the Polygon mainnet, I have already set up my RPC on MetaMask, which means it's just pointing to the main network. So I'm going to switch to the Polygon main network. And once I am sure everything is fine, you see, it's exactly the same process. You copy the bytecode. Like I said, this is for real. So we're going to copy the bytecode first. We're going to go and do our best practice of pasting this somewhere. So we have so we keep track of it. Remember, we did the same with our test network, but this is now the Polygon one. So if we go back, we can go ahead and make sure we are happy with everything. I do have to mention that 0.02 Polygon or Matic is quite cheap, but I'm going to just keep it like that. Usually when you work with Polygon, you can make this in the 1, 2, 3, 4, 5, 6. It's not Ether, but I'm going to leave it like that, because as soon as you change the smart contract now, you'll have to retype in all these details. But go ahead and make sure you configure it to your needs. So now that I click on transact, I will get the pop-up, and I'm going to be saying confirm. Now what happens is exactly the same process that happened when we were deploying to the test network on Ethereum. But now this is actually doing the transaction on the real main network of Polygon. And you'll see it pop up on the real mainnet, and we can go to the real OpenSea, and I'm going to really reveal it. So let's wait for this to finish. In the meantime, when this transaction is finished and it comes in here, or if it gets finished and you find it on the scanner, you need to copy that address and also follow the best practices, where we can actually then copy the address and put it in our file that we are saving all of our details to. I'm going to go ahead and speed this transaction up. Okay, it wasn't necessary. It's done. Means that it shows up here at the bottom. There's the address. I'm going to copy it immediately, the address, and going to Visual Studio, and just going to make a few spaces and paste it. This is now our main network's address, and you can actually scan this and it will be live there. So the next thing that I need to do is I can go back over to my remix. So the next thing that I need to do is just open it and make sure everything is fine. Maybe I want to mint one. So what I'm going to do is I'm going to unpause my contract. So I'm going to say this should not be paused, because I want to actually I want to interact with my smart contract. So let's kick that off so long, so that the contract starts running and it's done. And I want to mint a few. So I'm going to actually mint 5 for myself. And it says gas is not going to work. Why is that? Let's see why. Is it still paused? So let me go and see if it's paused. It's not paused, so I don't know why it would do that. So let me just quickly check. Oh, because we cannot mint more than 2 at a time. Fine. So let's mint 2. So I'm going to mint 2. It's going to pop up MetaMask, and I'm minting 2. And this is how you can do it from your little control panel, so to speak. Okay. Now, the other stuff that we need to now go and copy, which is very important for the smart contract, and I'll show you in a second, is the ABI of this contract, because this is what we'll use when we create the dApp. Okay, it looks like our transaction is successful. If we look at the MetaMask over there, it's gone through. So that is pretty cool. So the next stuff that you need to copy is the ABI. So what you can do is go to the Solidity compiler, make sure that you have the exact same smart contract that you use to deploy your contract in here. And then down here where it says contract, go and select your contract. Once you've done that, you can go ahead and copy the ABI. Okay. Then go back to Visual Studio, and I'm going to make a bunch of spaces and paste the ABI. So I'm just pasting in all the information that I need, right? I'm keeping track of everything, and I'm going to show you how useful this is later on. I'm going to make another, basically another file. So in the info, I'm going to say create new file, and I'm going to say Polygon contract. And this is going to be the Polygon contract that I used. Basically everything in here. So I'm going to press Command A to select the whole contract, copy it, go back and paste it in here. The reason why I do that is for if we lose the ability to actually salvage our remix. When I do that, you'll see that there's a way that I can re-upload this contract onto our remix platform, meaning that I'll have access to this beautiful control panel again. Otherwise, I will have to make use of the Polygon scans methods to kind of execute everything on there. But I can only use Polygon scan, for instance, Polygon scan over here, and Etherscan, if you have deployed this to the Etherscan or to the Ethereum network, if the smart contract is verified. How do we verify a smart contract? Well, at this point, this is why we have copied all this information. Let's go ahead and actually verify the real smart contract that we have just made for the Polygon network. All right. Here we have all the details. We have all the ABI constructor functions. We've got our ABI contract functions over here, the JSON format. And then also we have our contract address. So go ahead and copy the contract address that you have saved. Go back to your browser and go and search for it. You're going to basically search for this now either on Etherscan, on Polygon or Polygon Scan based on which blockchain you have deployed to. Now I can see that here's my smart contract and here is the Purple Eye PE smart contract, and there's already 2 minted, right? And 1 address owning it because we just minted 2. So I can see that there's 2 mints. How cool is that? Your smart contract is live and it's pretty cool. So technically, if I now go to OpenSea, let me go to OpenSea and check it out. So if I go to my profile, I should see that there's 2 new items in here, which are these eyes. So how cool is that? It is pretty cool. Now I noticed that they are on the Polygon network over there, but I'm not seeing the actual images. But I do see that it says Purple IV2, Purple IV2, and that is because like someone actually have created this before. So if we search for Purple Eye, there's actually a collection that exists that's called Purple Eye. I didn't know that. But now I've also got a collection, but it's V2. So that was an accident. But yeah, if there's a contract with the exact same name, it will show up like that. Now, I don't see the image yet, and I think it's just because OpenSea is a bit slow with this. So if I maybe refresh the metadata, I do know it is pulling in metadata. And the reason why I know this is because it says Purple Eye there, and in the description, remember, we typed in this image is hidden. So it is pulling it in. I think it just takes a bit of time for it to, fully populate because it's a new NFT or something like that. But we can go ahead and test it. Like I said, if you want to always go and test and make sure everything is fine, just go and query that token URI. So maybe we can query number 1. We can see that this is the JSON. And again, we can just go and replace it in there. Once we have it, we can see our image is located at this endpoint. So we can then replace that. And if we hit enter, there's our image. So OpenSea just takes a little bit of a while. It also did this just now on the test network, so nothing to be worried about. All right, so that's what we have for our purple Eye now. And I'm also going to just go in here. I'm going to try and refresh that metadata just so that if we come back here, that this will already be showing. So, all right, we will have to wait for that to reload. While we wait for that, like I said, we basically have our contract now set up in place. Now, the important part here is to verify the contract for us to, on a later stage, either interact with it directly on Polygon Scan or Etherscan. Like I said, this is a contract that can be deployed to both networks. You can see that we have a read and a write, but there is no ABI and someone needs to verify the source code. Because you are the owner, it's very advisable that you do it. So we're going to click on verify our source code. And this process is very simple. So let's fill in the details to verify our smart contract. What we can do is make sure that this is our smart contract address. So we can verify that by going to the details that we've copied, and indeed it is. So the next thing is we need to select a compiler. To find that out, we can go back to Remix, go to our compiler section, and see that we used 0.8.7. So when we go back to Polygon Scan, we can select, well, first we need to select a single file because we didn't use multiple files, we used a single file. And then we select our compiler, which was 0.8.7. And then lastly here it says if there was a license. To find out the license, again, you can go to Remix and scroll all the way to the top of the contract and go and find our license, which is a MIT license. So we can just say this is MIT. And then we hit continue. After that, Polygon Scan is now going to ask us a few more questions. And the first question is going to ask us, was this optimized? And yes, we did turn on optimization. Remember when I said turn on enable optimization over here? That's the only thing it refers to basically. Then what we can do is we need to paste our entire file in here. Now I already told you to go and copy your contract. You can either copy it again from Remix or copy it from your contract that you've saved it now as your info files. Let's go back. Let's paste the contract in here. Lastly, it's going to ask you for this ABI, encoded ABI, constructor arguments. This is only needed if you passed in constructor arguments when you deploy a contract. And indeed we did, because we filled in all this information. That's why it was very crucial to copy this. If you haven't done that, it's very difficult to go and verify it afterwards. Remove everything in this file, then go to Visual Studio Code, go to this Polygon file that we have copied and pasted, and then go and check this last bit of the bytecode, right? And select everything up until the last trailing 0. So your bytecode might look a bit different, but you'll see that it all looks kind of the same with a bunch of zeros. So you'll see that there's a line of 0, line of 0, line of 0, and then there is the last line of 0 here at the top. You can see it ends at the 2 and then it starts with 0 and it has a long trailing 0 piece. Take everything from that 0 all the way to the last 0. Copy this and then head over back to Polygon Scan, paste it in there and say that you're not a bot. And once they are verified you're not a bot, you can click on verify and publish, and it should go through on the very first try. A lot of people are struggling with that, and the reason for that is because they didn't copy the ABI encoded data when they deployed the smart contract. So this should take a few seconds and then our smart contract should be verified. Let's see. Perfect. So it says successful, everything worked out. There's our smart contract, there's all the bytecode, and it's looking good. So from now on, we can basically go back to our smart contract. And by the way, we should be able to search for it. Let me just go back. We should be able to search for it here in the search bar. So if we type in purple eye, there we go. That is our smart contract. So you can even search for it like that. But that being said, if we now click on the contract over there, you'll see that it's verified, meaning that we can actually query everything in here. And this is very good, because now technically we do not even need Remix. But that being said, there's a bunch of stuff we can query, but we can also write. So when you read contract and write contract, reading and writing are two different concepts. Where I told you about reading a contract is the free kind of functions of the contract calls, where writing actually takes some gas that you need to provide. It's the same concept as looking at these orange buttons as writing plus the red one, and the blue ones as the reading. Okay, so you can also withdraw from your smart contract when you are doing this from Remix or from Polygon Scan or Ether Scan. What you do is you can go to the right contract and you need to just verify and log in with your MetaMask wallet. So let it just load. You can see it asks you to connect over there through Web3. So I'm going to connect. Then you can go down and alter everything in your smart contract. You can reveal, you can pause the smart contract, you can do everything you want to that you are able to do in Remix, but this is only after you have verified your contract. And that's why it's very important to follow the steps. But let's say you want to withdraw. Now this was very confusing for a lot of people. This withdraw method all of a sudden has this field, right? And it's strange because on Remix, it doesn't. It is just a withdraw. Well, on Polygon Scan, that field is basically the value field. And that's why it's there. So please, if you withdraw, do not put a value in there. You will only be sending money to your smart contract. So if you want to call the withdraw, put a 0 because you don't need to send money. You're just withdrawing because you are the owner and you can simply call it. All right. And that's all how it works. Basically from Polygon Scan or Ether Scan, the verification steps are the same. The way you call smart contracts are the same. Everything is the same. And there you have it. Now you are done and you have a successful contract on the blockchain, which is verified too. Let me quickly show you some nuances and tips and tricks with Remix. Let's say you got back to Remix and for some reason your contract was gone. You closed the browser, you don't know what to do. Don't panic. All you need to do is head to the file where your smart contract was saved, go and copy that, go back to your browser, paste it in there, wait for it to get a green tick over here on the left hand side, then go to the deploy and run transaction section. Make sure that you are on the environment injected Web3 and that your MetaMask is pointing on the same network that contract was deployed to. Next, go back to Visual Studio or wherever you have saved your contract address if you've lost it, and you can copy that, go back to your browser, and then you need to paste it in here, address, right? Do not go and deploy this. You need to also make sure that you're on the right contract. So make sure that you're on Purple Eye contract. Even though this looks tempting to go and enter these details again, do not do that, because all you'll be doing is deploying another instance of your contract on the blockchain, and that you don't want. You want to interact with the same instance if you want to do it through Remix. Otherwise, you can just carry on interacting with your smart contract on Polygon Scan or Ether Scan if it was Ethereum. Okay, but that being said, if I click Add Address, you can see that I've got the address back. And how magical is that? Now, if I click on Total Supply, it should be 2 because it is 2 and it is reading from the right contract. Just so by the way, it took about 10 minutes for OpenSea to realize our metadata is there and the two images are now live and you can see them. Let me go and show you how you can now reveal the metadata from Polygon Scan or Etherscan. Like I said, you click on contract, you connect your wallet, and once you are connected and go to the right, you can just say reveal. Once you do it from here, it is just the same as if you were to do it in Remix. And that's why this is a cool thing to know, so that you don't always have to depend on Remix, because everything can be done from Polygon or Etherscan. Let's wait for that transaction to finish, and then we're going to just refresh the metadata. I'm going to maybe speed this transaction up a little bit so it happens a bit quicker. As we can see, the reveal is successful. So now let's go back to OpenSea, and then once users are on their NFT, they can just hit refresh metadata, like I said. Let's go back to the collection. Let's hit refresh on the other one. And if you want to do this in bulk, I think you can contact OpenSea and just tell them to refresh all your metadata for the whole collection. But that being said, as soon as one is refreshed, I think it triggers something in OpenSea that tells it to go and automatically refresh all the other ones. If we refresh this page now, or maybe give it a minute or so, you'll start seeing that the actual names get populated. For instance, we still have purple eye over there and purple eye over there. If we open the NFT, it should start saying maybe this is #1, and the description should change along with the image, and it would have properties. So let's give that a second. I'm not going to wait for too long, because I want to actually show you the next part and the final part, and that is actually hooking this contract up that is now live on the blockchain, again, Polygon or Ethereum, to the minting dApp. For the third and final step, you have now downloaded in the previous tutorials, remember the Hashlips minting dApp, this one. So go ahead onto your Visual Studio Code and double click on that folder. You will now see that it has a React.js-like structure, and it's very simple to start this up. All you need to do is start a new terminal. So click on terminal here at the top, say new, so that you have a terminal down here. And we follow the same process as we did with the creation part. So we first have to run npm install. So type that in the terminal and hit enter. This will install all the dependencies that we need to run the dApp, and we only have to make a few different variations, changes inside the config.js or JSON file. And then once we have changed the config file, it should automatically update to our minting dApp. And I'll show you how you can customize this to your needs, and then you can simply go and publish this on a shared hosted service. You can host it on GitHub Pages. It is simply a web page. Let me show you how easy it is to actually run this application. Now that you have installed all the dependencies, all you have to do is run npm run start at the bottom of your terminal. Once you do that, it's going to start up an application and most probably open up a localhost server on your browser. This is very cool because this is how you get to test it out before you actually need to build it. So let it run. It's busy running at the background now. It's just opened up on localhost port 3000, which means it's running locally on your machine. You can just check the progress by going back to Visual Studio, and you see that the server is busy starting up. Once the server is up and running, it's local, so it can just be viewed on your local machine here. So what you will need to do is, after you are happy with your changes, and I can see that it's now running. So if we go in here, you can see the local dApp running on your machine. But basically, after you're happy, we're going to do a build, and I'm going to upload it to a shared hosted service. Let's see how we can customize it. But let's first talk about what is happening over here. So firstly, This is a dApp that you can reuse. And there's a few nuances that you need to know about configuring this dApp, but once you are used to it, you will be able to make multiple projects using this dApp. What you can do is it will be connected to your smart contract and it will have your details and everything is customizable. If you click on connect, you'll see that there's buttons popping up where users can actually decide to mint more than one NFT. And if they go and mint, it will actually go and try and mint 4 NFTs. How do we customize it to our needs? Let's take a look. So the place where you want to go and customize this dApp is mostly in the public folder. There is, however, a small exception for what I did. I made the minting limit 2, so I might need to go and change something in the source folder, but I'll show you how to do that as well. So let's take a look at the files that you can quickly replace to create your own minting dApp. You can open the public folder and you'll notice there's a config file in here. Inside the config file, there's your images. Now, you can go into your images and you can see that there's a background, a GIF, and a logo. Now, I've already prepared those files in here where I have a GIF, I've got a background, and I've got a logo. Now, all you need to do is you basically take those images and place it inside of that images file or folder. So you go and replace it. And once it's replaced, you can simply go back to your dApp. And you can see that my logo is updated. There's a new background at the back, and I've got this cool GIF of this eye. So these eyes look freaking cool. It actually looks creepy, but anyway, you get the idea. We can go back, and after you've replaced your images, we can have a look at the theme. So in the theme.file.css, I've made it so that you can choose your colors. Now you'll notice that there's a primary, secondary, and accent color. The primary color is the color that's most visible on the screen, but also it has a primary text. For a good design, always choose a contrasting color for your primary text or your secondary text or your accent text. For example, if I were to select this purple, I can see here at the top that white text works best. If I go lighter, darker text starts working better. If I drag it around, you can see there at the top. But I'm going to choose purple, maybe that purple, and then I'm going to leave my white or my primary text as white. Next, what goes good with purple? Well, if you look at color schemes, yellow generally goes good with purple, but I'm going to make it blue rather, like this blue. I like this cyan kind of blue. I can see that a darker color works with that, so I'm going to try and make a darker color over there. And this accent is usually the box. Now, maybe the box we can leave as white with some black text. Let's see, just by doing these few layer configuration changes, how different the dApp starts looking. This is pretty cool, but it's not hooked up to our smart contract yet. So the only thing that you will need to do to hook this up to your actual smart contract, and keep in mind this is for Polygon and Ethereum, both will work, you just have to configure the settings. Go back to Visual Studio and click on the config.json file. You'll see that it requires a few different fields that you need to update. So basically the smart contract over here is simple. So we can go to Polygon scan. Let's go and copy that. We go back to Visual Studio Code. We're going to paste it in there. If you want the scanner link, you can simply just call maybe this. And let's just click on the contract address itself to get a scan link. So I'm going to copy that. I'm going to paste that as my scan link. Then I have a network. Now I want you to notice something. If I change this to Ethereum and I change that to ETH, because that's the symbol, and I change that to 1. I want you to see what happens to the dApp when I save it. So I'm going to save this dApp, and then I need to jump back to it. There we go. So this dApp now is configured to work with Ethereum. You can see that it's charging ETH, and it's also saying connect to the Ethereum mainnet. If I say connect, it's going to say change network to Ethereum. So I actually have to go and make that change in my MetaMask, because this is very cool. It's automatically updating and realizing that we need to connect to the Ethereum network. So that's just what I wanted to mention over there. But seeing that we are working with a Polygon smart contract now, that's why I'm going to leave it as Polygon. So Polygon's main network is 137, Matic is the symbol, and then also Polygon is just the name that I'm going to use. We're going to change this name now to be Purple Eyes, but let's put a space. So Purple Eyes, my symbol is going to be PE, and then the max supply is 50. Now the cost, we need to work this out. I know that I said that we are going to sell this for 0.02, remember? So I need to put this in here. Please be aware that this is the display cost. You need to copy this and take it into some kind of converter. So a good converter is this website where you can put your ETH in there. And even though this is Matic, you still work with decimals of 18. So you can put your ETH in there, just pretend this is your Matic, and then copy the weigh amount. Go back to the configuration and put your weigh amount in there. Then the marketplace is going to be OpenSea, but if we want the actual link, we can go to our OpenSea link and check. It's updated the metadata, guys. How cool is that? Our Purple Eye collection is live, and it is actually so live that you guys can actually go and buy them. They are really cheap, 0.02 Matic. But anyway, what I just wanted to show while we are here, you can see that all these traits have been pulled in, and these will get percentages as people start buying the collection, and it's busy growing. So that's pretty cool. But anyway, let's go and copy our marketplace link, which is that one, and we can go back to our dApp. We replace it over there, and then there's an optional parameter. You notice that on our current dApp over there, there's a background. You can simply switch that off by changing this value to false, like so. If you do that, you'll see that there's no background, but I like the background, so I'm going to leave it in there. Perfect. You are basically done, but there are a few changes that you still need to make. You need to basically go and put your ABI that you have copied into this file over here. You need to replace it, otherwise it won't have the correct ABI settings that it needs to use. Theoretically, it should be the same ABI because I've used the same contract. So let's try this out, but in a safe way and making sure that it will always work. Like I said, you can get your ABI if you go to your remix and you go and select your contract. Remember, like so. Just make sure you have the right contract and then copy the ABI. That's why we've saved it before for this purpose as well. But going back to this file over here, the abi.json, we can select all, and I'm going to paste it in, and then I'm going to hit save. Perfect. So now everything is hooked up. The only few changes that you can make is in the index.html page. If you want your title to be different, you can change it over here, and you can just maybe type the purple eye and new mint your PE NFT, right? And that's pretty cool. So you can change it there. And then what you need to do is you need to add a logo that is 192 pixels by 192, as well as a 512 by 512 and a fav icon. and that you can just simply create these images and replace them. In your manifest file, which is the last file you would like to change, you'll see that there's a short name and a name. This is basically if the app is basically saved offline. So it's good practice to just change that out too. So I'm going to do that. Like so. So now that we have the purple eye and everything is set up, I can go back actually to my browser and check out the dApp. You can see that indeed we have 0 out of 50 minted because we're not connected yet. If I try and connect, it says change to Polygon because our contract's on Polygon. So I'm going to swap it out. I'm going to say go to Polygon. Perfect. Then I'm going to connect. It says we can buy. There's already 2 out of 50. I'm going to try and buy one. One caveat that I just want to share is remember that in our smart contract, we made the minting amount very, very low. Now, the problem with that is our dApp will allow us to go over that and it won't allow the person to mint. If you want to rectify this, you can simply go into the program, go into the source directory in app.js and scroll down to the part where it is controlling this increment part. There it goes and decrements and increments to 10 and that is what the limit is set to, but you can change it and I'm going to make it 2. I will create, however, a nice configuration for that. I just didn't think of it at the time. I'm just going to save that anyway, but you probably don't need that if you have bigger minting amounts than 10. So just going back, I'm just going to refresh my app, I'm going to connect, and now you see I can't go higher than 2 or lower than 1. I'm going to try and buy one. So I'm going to click on buy. It's going to pop up my MetaMask and it's going to tell me that I'm about to mint one. I'm going to pay 0.02 Matic, which is perfect. And if I click on edit, I can see that 285,000 gas is being sent. And the reason for that is because in our configuration.json, this is the gas limit. This is usually a safe gas limit to put for one mint. However, the app works if you increase the buy. The app works in a way where it multiplies that by the amount of NFTs that you're going to mint. Generally, this is more than enough and actually a little bit too much, but it's better to be safe than sorry. So if you are working with the Ethereum network, you might want to change these parameters a little bit, but for Matic it's fine. It allows for enough gas to fully mint the NFTs that's needed. And keep in mind, the gas that's not used will be sent back. So we can just reject this. I only want to mint 1. So actually I'll mint 3. So I'll mint 1. Let's confirm the transaction. It will say, and you can see that everything is updated. Purple eyes, it says mint 1 PE cost 0.02 Matic, excluding gas fees, minting your purple eyes, ... And it's now busy doing stuff, right? And these buttons are also frozen. You can't do anything. We have a disclaimer, which is always good to have on your apps, just to let people know that this is a reversible action. Then you can also click on this link over here. So I'm going to open it in a new page so you can see it goes to our contract address. And if we click on it, I can see that if I go and refresh, let me just see, it's supposed to have a new transaction taking place there, which it's not. So I just want to see why. I'm going to go into my transactions and it is saying that it is, well, it is minting. It should show up on our contract. So I'm just going to click on this contract and let me just see what's happening. So we've only minted these, which is fine. I do have the right configuration, so you need to make sure that it is the right configuration. And that is fine. That seems like it should be just working perfectly. But you never know, so let's just double check. Reveal, it's doing that. I'm not seeing the transaction taking place, and I'm not sure if that's because it's still busy working on a transaction over here. I'm going to try and just speed this up, not by that much. I'm just going to speed it up a bit because I want to show you this live process, right? So I'm just speeding up the transaction. Maybe that's why it's not reflecting on the contract itself yet, but it should. So I'm going to just refresh. Oh, there we go. It did mint 11 seconds ago. Perfect. So if we go back to our dApp now and we refresh and we connect, it should say there's 3, and indeed there is. So I'm going to mint 2 now because I want to see this live update, and I'm going to say confirm, but I actually want to just edit my gas price to be, let's make it 20 so that it just happens a bit faster. You also notice that it increased the amount being sent to 0.04. So now, after this mint is successful, this should update and be 5. So let's check it out. I'm just going to open MetaMask and see the transaction taking place over there. And while we wait, guys, I really appreciate you sticking around for this big tutorial. I'm sure that this is going to be a very long one and has been, but in essence, this tutorial will help you so much to understand all the little things that you might have gotten wrong in the past, and I hope it really does. I hope it really does help you guys. It's been successfully minted, so it hasn't updated yet, but if I refresh and connect, it should be 5. Perfect. And there you can see that 5 has been minted. We can go ahead and check the contract. We can refresh the contract and see that there was another one and another one minted. This one came through. So if we go there, we can see all the tokens being minted here successfully. How cool is that? So the last step, in order for you to host this somewhere, you can simply buy a shared hosted service to put this dApp that you have over here onto. But you can't just simply put this whole folder. You need to build it first. The last piece of the puzzle is simply running npm down here in the terminal, run build. So npm run build. When you hit enter, the application will simply bundle up everything and build it in a build directory over there. Wait for it to complete. So once it's done, all you need to do is right click on the build, reveal in Finder, or if you're using Windows, just go and find the build folder. All this content over here you can now upload to a static shared hosted service. So the very last part is to actually select all those files in the build folder, compress them, go to a shared hosted service. You can choose any shared hosted service. I'm using my local country's services because I'm living in South Africa, but if you're living overseas, maybe a service like Ionos might be good. It can be a very cheap service. It doesn't have to be something exclusive and powerful, because it's simply a place for us to host our dApp. Now I'm going to say upload, and I'm going to upload this archive file. Now, while this is uploading, basically I'm just going to simply extract it, and then once everything is uploaded and extracted, I can access this dApp by going to the Nerdy Coder Clones collection. I am actually uploading this dApp quickly in place of the Nerdy Coder Clones just to show you guys how to do this. But after this tutorial, I'll take it off and you guys can mint your Nerdy Coder Clones again. So there's the zip file. I'm going to extract it over here. And there we go, it's extracted. So now, if I go to the Nerdy Coder Clones, I should see my new dApp. And there we have it. If I go to the Nerdy Coder Clones.online, I've now simply replaced my Coder Clones DApp with this one, and I can still connect. It has 5. It is hooked up. It's ready to rock, and I hope you guys can do the same. If you have uploaded your DApp and your images aren't showing, for example, these GIFs aren't showing as well as the background image, well, go back to your hosting service and find where the images are located. Then go and see that they all have at least 0644 permissions. So I'm going to change that to 644 and this one as well. Once you've done that, you can also give them a higher permission like 775, but at least 644 is necessary. So when you refresh, your images will show up. I really hope this tutorial helped you guys. I just want to mention that if you get stuck, please go and ask on the Discord channels, which Discord is very organized. There's frequently asked questions and a community that's willing to help. So go on there and ask your questions. You can also go on to Telegram and keep an eye out on our YouTube channel for more awesome content. I really hope that you guys create awesome, cool dApps like these. And if you want to go and buy a Nerdy Coder clone and support the channel, by all means, go and do that. You can go to nerdycoderclones.online, buy one. It's 100 Matic, and come and join the Discord and show it off. But that being said, I also just want to thank each and every one of you for being a part of this community, helping each other out, and always giving me the most positive feedback that anyone can ask for. I am really proud to make these videos for you guys, and I hope this long video deserved a thumbs up or at least a subscribe. So till next time guys, I'll see you on the code side. Cheers for now.